Hello, ninth grade extended students. Today we are going to learn about the equations of circles. The center radius equation of a circle is this: x minus h squared plus y minus k squared is equal to r squared, where h comma k is the center and r is the radius. So as an example, I'd like to write the equation of a circle with the given information. So I'm going to start with A. My center is 0, 0. So first, let's remember what the equation is. And we just fill in the blanks. If my center is at 0, 0, it's x minus 0 squared plus y minus 0 squared equals my radius squared, and the square root of 11 is just 11. And again, of course, when I subtract 0, it's like nothing happened, so I can write my equation just like that. For part B, same kind of idea, fill in the blanks. X minus h is 3. Y minus k is 5. And my radius is 6, so this is equal to 36. I'd like you to pause your video, write the equations of the circles for part C and D, and when you're ready for the answer, press play again. Here are the answers. So, x minus a negative 2 is plus 2, y minus 5, and then 4/3 squared, 16 over 9. Finally, part D, I had to find the center off of the graph. The coordinates were -4, and my radius here was 4. So filling in the blank, that is the equation of the circle. The center radius form is nice and pretty. It allows us to find the center very easily and the radius very easily. But there is another form called general form, and it looks like this. I have all of those perfect squares multiplied out, and then I have coefficients in front of them. Now, this form is not always a circle, but when the coefficients a and c are equal to each other, then it is. So a, c, d, e, and f are real numbers. In order to make this look more like a center radius equation, we can use a process called completing the square. So I am going to transform this equation into center radius form as I follow these steps. The first step is to move non-variables to the other side and put x's and with x's and y's with y's. So let's do that. Let's put our x's together and our y's together. And I'm going to move 20 to the other side. And I did leave a space after each of the x's and the y's because we're going to complete the square and I'm going to put something in there. So step 2 is to factor out coefficients in front of the squared term if needed. It's not now because there is a 1 in front of my x squared and there's a 1 in front of my y squared. Step 3 is to cut your non-squared term's coefficient in half, square it, and add it to both sides. So again, we're completing the square. We want this thing to look like that. So to make this a perfect square, I need to divide this by 2, which is 5, and square it. So that would give me 25. But when I add 25 to the left, I have to add 25 to the right. And then I have to do the same with the y's. Cut this in half, that's 2, and then square it, that's 4. And then if I add 4 to the left, I have to add 4 to the right. Now, I need to next factor the left side and simplify the right. So I'm going to factor this as a perfect square, and I'm going to factor this as a perfect square. This becomes x minus 5 squared plus y plus 2 squared. And then if I add 25 to 4, that's 29. Subtract 20, and that gives me 9. Now it is in center radius form. Now, if I look at this equation, I can very easily see that the center is at 5, -2, and the radius is 3, the square root of 9. Next, I'd like you to try to do each of these. Press pause on your video. When you're ready for the answers, press play again. Here are my answers. So I moved my x terms with the other ones, and there is no other one, so now I put my y's together, and then I cut the 4 in half and square it, which is 4, add it to both sides, factor, that's equal to 16. My center is at 0, -2. And for part B, same kind of idea. Make sure the x is together. If there was another y, I would move my y over, but there isn't. So cut this in half and square it. That's 1. Add 1 to both sides. And now factor. My center is at 1, 0, and my radius is the square root of 9, or 3. Take a minute, add this problem to a blank area in your notes. I want you to see what it's going to look like when I change general form to center radius form when I have leading coefficients on my x squared and my y squared term. So the steps: move all your x's together. So I have 4x squared minus 24x, and move my y's together, 4y squared plus 8y, and then I'm going to move my non-variable term to the right, so -15. Now I'm going to factor out that leading coefficient. 4 times the quantity, x squared, minus 6x, I'm going to leave a space there, plus 4 times the quantity, y squared, plus 2y, leave a space there, equals -15. Now it's time to complete the square. So I'm going to take -6, divide by 2, and square it. So divide by 2 is -3. When I square it, it's +9. Take the 2, divide by 2, get 1, square it, add 1. Now, we are not simply going to add 9 to the right side, because this 9 is getting multiplied by 4. So we have to add 4 times 9, or 36. And then here, we don't add 1, we have to add 4 times 1, or 4. So now I'm ready to factor. So x minus 3 quantity squared plus 4 times y plus 1 quantity squared is equal to 40 minus 15, which is 25. And now I'm going to divide this whole equation through by 4. So I get x minus 3 squared plus y plus 1 squared is equal to 25 fourths. So my center is 3, -1, and my radius is 5 halves. Now, the way I did this absolutely worked. An alternative would be that I could divide this whole equation through by 4 from the very first part. And then I would not have had to worry about adding 9 times 4 or 4 times 1. The problem with that is I end up with fractions, and I like to avoid fractions as much as I can. But again, it would not have been wrong to just divide the whole equation through by 4. So, have a great day. Work on the assignment I posted online, and hopefully I'll see you tomorrow.